We all have electrical activity in our brains. Right now, the combined activity of thousands of neurons is shaping how your coffee tastes, how awake you feel, and even how much you learn in the next 3 minutes. During a seizure, this activity becomes suddenly uncontrolled and imbalanced. 10% of you will experience a seizure at some point in your lives. But this doesn't mean that you have epilepsy. Epilepsy is a very specific diagnosis characterized by an enduring predisposition to generate unprovoked seizures. 2/3 of patients can control these seizures with medications, but 1/3 cannot control these seizures with any combination of drugs. Over years, these uncontrolled seizures kill brain cells, impair memory, language, and more. Imagine how this would impact your ability to remember everyday words or even compete today. Uncontrolled patients highlight an unmet and dire clinical need. Drugs that interrupt or reverse epilepsy, not just control seizures. Mystery surrounding what causes epilepsy has been the greatest barrier to finding such drugs. Now, we have strong evidence that inflammation of the brain underlies epilepsy. If you've suffered a fire ant bite, you know the pain, heat, swelling, loss of function caused by bodily inflammation. The same process happens in your brain, and it's mediated by cells called microglia. Microglia are the brain's secret gardeners. They sleep until needed, waking up when the brain is damaged or infected. Then they orchestrate inflammation, repairing damaged areas or snipping away dead or unwanted cells. As with weeding a garden, inflammation is healthy when needed, but destructive when it endures despite being unnecessary. In epilepsy, inflammation makes brain cells hyper-excitable, dramatically increasing the chance of a seizure. Before, we could only study this post-mortem or by probing tissue samples. But now, with magnetic resonance spectroscopy, or MRS, we can look at this in a living person. A routine MRI gives you a picture of brain structures. MRS tells you what's inside those structures. So we can measure the amount of microglia, we can measure brain temperature. If you think about the warmth of a fire ant bite, brain temperature also increases during inflammation. It's amazing that we can study brain temperature without sticking a thermometer in your brain. With this, we can study 1, do uncontrolled patients have brain inflammation? 2, is it reduced with a drug that targets this process? It's a really exciting step on the path to finding drugs that treat all epilepsy patients, not just 2/3. Thank you.